Okay. Hi guys. Yep. All right. So nice to see you all again. Can you hear me clearly? You know.
Yes, we can hear you.
All right. Nice. Nice. Good. Okay. So I'll just be sharing my screen, and I will just take it from there. Okay.
I can't see your screen.
Yeah. I'm just sharing now, so it's still loading up. Okay. Okay. So you can see my screen, right?
Yes, we can.
Okay. Good. All right. Uh, so full screen. All right. So, good afternoon, guys. Oh, good day, guys. Once again. Uh, so yesterday we had more like an intro to FVM, knowing what FVM is all about, the basics. Checked out what Remix was. Checked out what Remix was. Checked out tools we could use to build on the FVM, and we also added the Filecoin calibration testnet to our MetaMasks after setting up our wallets. We also had a smart contract deployed to the calibration testnet as well. And we also saw how to interact with these smart contracts that we deployed yesterday, right? Okay. So I think today we'll just have a little recap of what we did yesterday and then go into an overview of FVM's architecture, how everything works under the hood. Yeah. Sorry, I just realized I was talking and my mic was muted. So, from yesterday, FVM is the execution layer of the Filecoin blockchain, enabling smart contracts, which are called actors in Filecoin, written in WebAssembly compatible languages to run natively on chain. So, uh, WebAssembly compatible languages, these are Solidity, Golang, C++. But currently, we have support for only Solidity on FVM, and we have plans to there are plans to integrate or enable development in other languages in the nearest future. So contracts written in WebAssembly compatible languages to run natively on chain. So that's basically what FVM is and what it helps us to do on the blockchain, as Filecoin blockchain as the underlying layer. Right. So basically, so that it brings programmability to Filecoin. So Filecoin is the underlying layer, or in this case, we call it the layer one, and FVM is basically the EVM for the centralized storage. So Filecoin makes it possible to store files online using IPFS, and then FVM makes it possible for you to run computation on those data you stored on Filecoin. So basically, the Ethereum virtual machine, but for decentralized storage in this case. So also looking at what makes it different from other blockchains we have. So in this case, other blockchains can refer to Ethereum itself, can refer to Arbitrum, and just every other blockchain we have. So we see that it's built for data-centric applications. So because the base or the main layer of FVM is Filecoin, you have the ability to run whatever you need on decentralized data, however large it can be, or however small it can be as well. So basically, it's built for data-centric applications. That's why we have data DAOs, we have data retrieval applications, we have subnets built on Filecoin or EVM or FVM rather. Then it supports WASM-based actors. In this case, actors can also be called contracts. So just to make it easier for you, actors are smart contracts in FVM. So any code that compiles to WASM can be deployed on the chain. So currently we have Solidity and the publicly recognized ones. We have Solidity, we have Viper. These are like one of the most popular smart contract languages we have right now for EVM based chains. So these are all supported on Filecoin and then can be used to deploy smart contracts. Okay. So it also uses IPLD for state storage versus EVM's KiCac 256. I'll not say much on this because it's quite technical, but it's just describing the state storage layer we have on FVM instead of what the EVMs use or the default storage layer on the EVMs. Right. Now, Filecoin Virtual Machine is also designed for interoperability, meaning we have native Filecoin actors, we have EVM actors, all working on the same blockchain. This is why we have the OX address and we have the F4 address. So you can use Filecoin, you can send tokens to your OX address, you can send tokens to your F4 address. You can make interactions from your F4 address or from your OX address. So basically, it helps you operate with various addresses on the same account. So it makes it interoperable as a user, and then it improves the UX as well as the user experience. So we have powerful actor model with built-in methods. So we have constructor methods, we have invoke methods, and all these are methods, inbuilt methods on chain. So why does EVM matter? The FVM, why does it matter? But before we go to this, I'd just like to create a quick contrast to Ethereum or EVM. So I'll contrast Filecoin, the FVM, to Ethereum, that's EVM. So the first one, I don't have this on slide, so I'll just be saying it and hopefully you can follow as well. So for the execution layer, Ethereum's execution layer is just the EVM, so that's the Ethereum Virtual Machine. But on Filecoin, the execution layer is both WASM based and Ethereum based. So we have WASM, which is a native execution layer, and then we have FEVM, which is Filecoin's Ethereum Virtual Machine layer. So then the second one we have is actor model. So Ethereum is account based. So we don't have actors on Ethereum, but on Filecoin we have actors. So Ethereum basically uses accounts and smart contracts, while Filecoin uses actors. And then on Ethereum, there's no native storage logic, while on Filecoin we have a native storage logic. So you can upload files to IPFS of Filecoin directly through the FVM. And then for language support, smart contract languages, we have just Solidity on Ethereum based uh, blockchains, while on Filecoin we have multiple languages so far as they compile to WASM compatible code. So in this case, we can have support for Rust, we can have support for Go, we can have support for assembly scripts, and any other language so far as it compiles to WASM. And then lastly, our use case on FVM is basically storage first and data logic. So this is in addition to all other possibilities on EVMs. On EVMs, we mostly have finance, that's decentralized finance applications. We have staking applications, and basically applications that have to do with uh, money or finance. But on Filecoin, we have applications that deal with storage in addition to finance. So we have the way we have data DAOs on Filecoin, the way we have application on this storage, on this files that you on Filecoin decentralized storage. While on Ethereum, you're only limited to applications that merely focus on finance. So you can build contracts that govern data access, you can build contracts that run storage markets and retrievals on FVM, which are not possible on other Ethereum based networks. All right. So we can then go forward to, okay, so why FVM matters. I think we've discussed on this already. And then we'll go next to the FVM architecture. Okay, is everyone following? That's everyone on the call here. All right. So for the FVM architecture, the first thing we're looking at is the actors layer. All right. So The actor layer is basically the first layer or the user-facing layer. So this is what every user can interact with. So basically, these are your smart contracts. Contract that every user can interact with. So whatever call is being made to the chain using your smart contract go directly through the layer. So example was our smart contract yesterday that we deployed. The call we made to that smart contract was directly interacting with the actors layer, which is the first layer user encounters when visiting or using the blockchain. So this is where your logic lives, and these are the smart contracts users interact with. All right. So actors are smart contracts written in Solidity or other WASM compatible languages. So we've spoken about the FVM's compatibility with multiple languages. So this is just another point stating that. So actors are smart contracts written in Solidity or other WASM compatible languages. These languages can be Rust or Golang or assembly script, any language so far as it compiles to WASM based code. Each actor is deployed as a WASM binary. So this is also reiterating what we said earlier, meaning every smart contract that you deploy on the blockchain is compiled or deployed as a WASM binary. So everything, whether Solidity, whether Golang, whether Rust, whether assembly script, everything compiles to WASM to a WASM binary first, to WASM bytecode before being deployed on the blockchain or on Filecoin's virtual machine here in this case. Right? And then each actor has methods exposed for dispatch. So these methods are methods that the user interacts with. So we have init, we have vote, we have store data. These are just sample methods. A method in a smart contract can be anything you call it, anything you name it to be. So yesterday, I think we had store in our block in our smart contract. We had one to retrieve. This was to see what number we stored on the blockchain. So all these are methods on our smart contract. So one good thing about Filecoin is you can call other smart contracts, other actors via syscalls, and basically smart contract or actors are like independent services running on chain. So the way you have a service, maybe if you're building up an application, you have a microservice that handles maybe user information and every user related function. You have one microservice that handles maybe financial functions and all that. The way you call or interact with these microservices is similar to what we have on FVM. So if you have one smart contract for storage or just user storage, you have another smart contract for handling maybe the financial part of your product if you have that. So you can use multiple smart contracts in FVM. That's in a single application on the FVM, and then call these applications through system calls on your actor or on your smart contract. I don't know if that's clear. So we have the FVM runtime layer. Okay. So we have the FVM runtime layer. All right. Seems like it should be just a little bit. Just give me a minute. Okay, so we have the FVM runtime layer, and this basically manages actor execution within the Filecoin chain. So every call you make on or with to your actor is managed by the runtime layer. Yeah. And then this runtime layer provides a deterministic environment for WASM and binaries. It dispatches system calls to the underlying blockchain state, ensures gas accounting, message handling, and state transitions. Okay. So basically, what it does is every call made to your actor or to your smart contract is handled on this layer. So this layer that handles every smart contract related call, be it user to smart contract, be it smart contract to smart contract, everything is handled on this layer. So basically, you as a user don't write to the blockchain directly, and then what you do is when you make a request or an interaction with the smart contract you deployed or with your actor, the actor you have deployed asks the FVM to do it through syscalls, and all these are handled on this layer, which is the runtime layer. All right. So next layer we have is the WASM execution engine. So basically, smart contracts that we deploy on the blockchain are compiled into WebAssembly or WASM, like we said. And then FVM supports WASM through Rust. So the reference implementation for the FVM is written in Rust, and that's like the official implementation. So execution is sandboxed, deterministic, and resource metered. This also opens the door for multi-language support. So Go, C++, and other languages. Like we've said before, because we have a system that runs on WASM-based code, various languages can be compiled to WASM. So we can support all these various languages over time. So currently we have support for just Solidity and Solidity related languages. But with time, we could deploy code written in Golang, deploy code written in every other WASM based language. Right. So we'll take a quick break and then we'll be back in a few minutes. So uh, during this period, I think if you have any questions, you can just note them down and then send them over, maybe as a chat or in the Telegram discussion group. And then I'll attend to them once we return. All right. No, I don't know if you can hear me.
I think there's a question.
Okay. Can we note them down? Then I'll attend to them once I'm back
Okay,
from the
that's fine.
meeting. Yeah. So I'll attend to them once I'm back in a few minutes.
Yeah, yeah. To me, are you watching?
Yeah, I'm still with you now.
Okay, guys. We'll be going for a short break. Uh, I'll be back in the next 1 hour. So I'll come back with questions, and then Timmy will give you just that. Thanks to me. See you in the next 1 hour. Right?
All right. Thanks.
That's
Yeah. All right. We'll see you guys.